century, currencies were protected by the intaglio printing process, where thick ink is aggressively pressed into the grooves of high-quality cotton paper. But that mechanical barrier has been breached. The US $100 supernote is a counterfeit bill executed with such precision that forensic experts consider its engraving work superior to the genuine bill produced by the Bureau of Engraving and Printing. US authorities found that these counterfeiters had sourced the exact 75% cotton, 25% linen paper blend used by the Treasury. They had also procured the restricted Swiss Jory intaglio presses required to manufacture them. When counterfeiters use the identical industrial equipment and raw materials as the government, the basic premise of secure paper currency is mathematically broken. State-sponsored counterfeiting is a long-standing military tactic. During the Second World War, the German Third Reich launched a covert economic attack aimed directly at the Bank of England. Under codename Operation Bernhard, the SS gathered 142 prisoners with backgrounds in printing, engraving, and banking. Their task was to systematically reverse engineer the British pound. The team analyzed genuine notes and successfully mapped 150 intentional security flaws hidden in the paper. By the end of the war, they had printed 130 million pounds in counterfeits, intending to flood the British economy and trigger a collapse. Static security features, like secret watermarks or unique paper blends, rely on secrets that can be uncovered. With enough time and state funding, any physical security measure can be replicated. To stay ahead of forgers, central banks had to move beyond stagnant designs. They had to create money that actively reacts to the environment around it. The first line of modern defense is optically variable ink, or OVI. This ink contains microscopic metallic flakes and liquid crystals. As light hits the surface, these structures reflect different wavelengths depending on the angle of view. On the US $100 bill, this technology is visible inside the copper inkwell. Tilting the note reveals a shifting green bell. This optical effect cannot be captured by photocopiers or traditional presses, rendering stolen machinery obsolete. The Treasury also introduced micro-optics, like the blue security ribbon. This blue ribbon is woven into the core of the paper fibers during the manufacturing process. The ribbon contains thousands of microscopic convex lenses, sitting above a printed grid of bells and numbers. Shifting the viewing angle creates a moire pattern, an optical effect that makes the icons appear to float and move in different directions. Many nations are abandoning paper. Central banks in the UK, Poland, and the Philippines now use polymer substrates. Polymer allows for transparent windows and 3D cinema effects built into the core of the bill. These advanced features rely on proprietary materials that are virtually impossible to acquire outside of official government channels. Modern banknotes have evolved from simple printed slips into mass-produced optical engineering devices. Yet even a physically perfect object has a vulnerability. This was the flaw that brought down the Nazi counterfeiting ring and the syndicate behind the 1925 Portuguese banknote crisis. In 1925, a criminal group used forged documents to trick the Portuguese government's official printing firm. The firm unwittingly produced over 100 million escudos in genuine, authorized banknotes for the scammers. These operations produced bills that were visually perfect. However, the forgers could not replicate the algorithms governing serial numbers. Bank clerks eventually spotted the same numerical sequences appearing on multiple notes in circulation. These duplicates proved that a physical eye test is no longer enough to protect a currency. A counterfeit bill can be a perfect replica, but its lack of a unique place in the digital record makes it a mathematical anomaly. Because of this, modern currency uses a dual-layer defense. Visual features allow the public to verify cash at a glance, while hidden, machine-readable data allows banking systems to check the underlying mathematics. The US $100 bill contains a security threat that glows bright pink under ultraviolet light, while the Chinese yuan utilizes nanoprinting that requires specialized scanners to detect. The next stage of this competition includes banknotes with integrated augmented reality, invisible digital watermarks, and embedded biometric data. The security of a physical currency now depends on this constant layering of optical and digital defenses. As long as nations issue paper and plastic, the technological arms race to safeguard that trust will continue.